Good morning. Happy Thursday. We're almost there. I've got one more day before I'm on a 3-week holiday from my day job. So I'm a teacher. And tomorrow is the last day of school before our winter holiday break. Oh man. I am looking forward to that. I love teaching, but it'll be nice to relax, refresh. I'm a little sad that I'll be out of town. I don't know exact dates yet, but I'm gonna be out of town for part of the Advent and Code, so I'm not gonna actually be able to solve every puzzle the day it's released and make a video. But that's okay. My students, really, I wanted to get through the first 2 weeks. I'm not sure if I'll make videos for days after yesterday. Yesterday might be the last one I do. My students aren't gonna get that far. I'll probably make videos, just not releasing them the same day. But we'll see. We'll see how this goes. We are doing day 15, Beacon Exclusion Zone. This is the Advent of Code 2022. Daily puzzles brought to us by who's the author here? Eric Wassel. Eric Wassel. Such a wonderful human being for making all these puzzles for us year after year. This is my first year doing it, but goes back to 2015. Awesome stuff. I've been absolutely loving this, enjoying it. And so far, with the exception of, what is it, day 11 had some weird... there was a trick that you just had to kind of know to be able to solve day 11 part 2. But all the part 1s, part 1 on every puzzle so far has been super doable by anyone who, I would say anyone who's completed an introduction to programming course, like a first semester course in undergrad or a high school course, middle school course. I have a bunch of middle school students who've actually completed up through day 10, I think I have a 10-year-old who's completed through day 10, both parts 1 and 2, which is awesome. Using, not 100%, I've given them a strategy to do it. So the hardest part about these puzzles is coming up with a strategy. What's your approach? How are you going to solve it? What is it even asking is a question that is tricky sometimes. But here we are, day 15, Beacon Exclusion Zone. You feel the ground rumble again as the distress signal leads you to a large network of subterranean tunnels. You don't have time to search them all, but you don't need to. Your pack contains a set of deployable sensors that you imagine were originally built to locate lost elves. The sensors aren't very powerful, but that's okay. Your handheld device indicates that you're close enough to the source of the distress signal to use them. You pull the emergency sensor system out of your pack, hit the big button on top, and the sensors zoom off down the tunnels. Once a sensor finds a spot it thinks will give a good reading, it attaches itself to a hard surface and begins monitoring for the nearest signal beacon source. Sensors and beacons always exist at integer coordinates. Each sensor knows its own position and can determine the position of a beacon precisely. However, sensors can only lock on to the one beacon closest to the sensor as measured by the Manhattan distance. That's something you'll have to explain to students. There is never a tie between where two beacons are the same distance to a sensor. Okay, so that's a good caveat there. It doesn't take long for the sensors to report back their positions and closest beacons. All right, so we have sensors at XY locations, and then we can sort of determine how far I can sense things. I guess the beacons, since it's a Manhattan distance, the beacons are sensing sort of a circle around them. That makes sense. All right, so this is sort of the circle around them. Consider the sensor at 218. The closest beacon is at negative 215. For the sensor at 916, the closest beacon to it is 1016. Drawing sensors at S as S and beacons as B, the above arrangement of sensors and beacons looks like this. Okay. This isn't necessarily a comprehensive map of all beacons in the area, though, because each sensor only identifies its closest beacon. If a sensor detects a beacon, you know there are no other beacons that close or closer to that sensor. There could still be beacons that just happen to not be the closest beacon to any sensor. Keith, my friend, good morning. Happy, let's see, Keith, it's gonna be happy Friday. Is it happy Friday for you? Anyway, good morning, G12345. G12345. Can I just call you G? Is G okay? Trying to say all those numbers afterwards. It's a little tongue twistery for me. But good morning. So happy to have you aboard. We are looking at this. I'm sorry, Keith. I'm sorry I was too critical. I was definitely being too critical. Yesterday's puzzle was so fun. I think it was my favorite puzzle so far. I ended up spending way too much time animating it. Let's see if I can. Oh, my hands are in the wrong. Oh no, I have numlock on. That's what's going on. It's like, why am I typing numbers? Where's that button? Even keypad? There we go. Day 14, visualize. This was just so much fun. Hang on. I ended up writing an animate. And I set it up so it could drop multiple chunks of sand at the same time. Let's do it with just the example real quick so we can see. This was so much fun. This was just, yeah, but I spent so much time getting this to work. Yeah. I want to make it even better. It will work for a large input, but it ends up crashing if it gets too big. This was just too much fun to write. Yeah, so this was super fun. I want to make it so that way it will sort of scroll down the viewport as the grains of sand start falling lower and lower. So you see how down here at the bottom, it's not finished. You can't see anything below that, and it's gonna crash as soon as the first grain of sand hits here. I wanna make it so when that gets that point, it will actually scroll down so that way you can see the lowest piece of sand, and then it'll only show that section of the display. Otherwise, you have to zoom out so far that it's not even fun to watch. But I had a ton of fun doing that one. What a cool puzzle. Today looked more scary than it actually is. We'll see. We'll see. I haven't finished reading it. I got too excited to share my visualizer. I have an audience. I had to show it off. Alright, so this isn't a comprehensive map of all the beacons there because each sensor only identifies its closest beacon. If a sensor detects a beacon, you know there are no other beacons that closer. So there's no ties. There could still be beacons that just happen to not be the closest beacon to any sensor. Consider the sensor at 8,7. Must be this one. 8,7. This is the closest beacon. So we have this I guess it's a diamond. I was calling it a circle because of the Manhattan distance, but I guess it's a diamond. That's interesting. It makes sense. It makes sense. This sensor's closest beacon is here, so you know there are no beacons that are closer, close or closer, that close or closer. All right, so we essentially have a scan here that tells us that there are no beacons. There's exactly one beacon when it's in our sort of search radius. This will be like a radius. None of the detected beacons seem to be producing the distress signal, so you'll need to work out where the distress beacon is by working out where it isn't. Okay. So given all of our sensors, the beacons that we're seeing, none of them happen to be the distress beacon. For now, keep things simple by counting the positions where the beacons cannot possibly be along just a single row. So suppose you have an arrangement of beacons and sensors like in the example above, and just in the row where y equals 10, so the 10th, well, I guess not the 10th row because we go negative, in row 10, y equals 10, you'd like to count the number of positions a beacon cannot possibly exist. The coverage from all sensors near that row look like this. Okay, so the hashes are covered and the dots are not covered. So if you were to look at all of it, in this example, in row where y equals 10, there are 26 positions where the beacon cannot be present. Consult the report from the sensor you just deployed in the row where y equals 2 million. How many positions cannot contain a beacon? Okay. This is interesting. We know we can calculate the radius of every sensor, right? So every sensor has a radius like this. And so if we have that radius, we can sort of create a range of numbers that the sensor has in a specific row. And if we sort of translate, so let's say we have a sensor, we want to say, well, what positions can it detect in a specific row? The idea is to, you can sort of think of it as there's a sensor in every row that has S-1, right? So if I were to move this sensor down one row and reduce its radius by, oh, is that right? So this sensor, yeah. If I were to move it here, what's the sort of range in that position? So we have S has a range of 1, 2, 3, 4, 5, 6, 7, 8, 9. So here it would have 8, 7, 6, 5, 4, 3, 2, 1, and 0. Yeah, so as we move it down, its radius sort of decreases by 1. So the idea would be translate this S, find the distance from a sensor to that position, and essentially reduce its range by that much. And then we have a bunch of sort of, every sensor can detect so many spaces in a specific row. And then we sort of, I guess we have ranges with a start and an end, and then you got to union all those ranges together. And then sum up the spaces in them. All right, so I think that's the approach I'm going to take. I'm going to take that approach. So I'm going to get all of my sensors, calculate their radiuses, translate them down to that position, subtracting it. If the radius becomes less than 1, we can just like ignore them. They can't detect anything in that row. Otherwise, we build up a set of sort of like rectangles and say, okay, what is the union of all these rectangles? Let's try it. This is a it's gonna bite me on part 2, isn't it? Part 2 is gonna want me to do some kind of, we'll see. Part 2 is always something horrible. Okay, so we have sensor. So we're gonna have a public record sensor, and a sensor has an int row, int row. I like the thing in row column. They love to do XY, and a radius of detection. Okay. And we know, well, the radiuses can overlap actually. We just know that there's only one beacon in there. All right. So then we want to sort of get the range. Public record range. And we only care about in this, you know, it's going to be int lower, int upper. Keep track of the lower range it can detect and the upper range it can detect in a specific Y. In a specific Y. So this is going to need to get a public range. The range it's going to get is going to be for int row. It's going to give us back a range within a row. So given a row, what is the range it has there? So we sort of need to, as we move it down, let's think here. As we move it down, I need to shift this dot row. What's the difference? Minus row. Int row diff equals this. And ooh, this is interesting because my range could eventually be, I need sort of like to be able to identify that this thing doesn't detect anything. So I think maybe I want to return a maybe range. So this can be null, and null means that there is no, it doesn't detect anything in that row. That's fine. I'm not looking at you. I'm noodling through the process in my head. I don't understand why this has an error. What are you complaining? Oh, I gotta give this thing a name. Find range at row. Okay. Gee, if you're looking at us, we have no comment yet. That's funny. So this, and this should be our absolute. Yeah, math.absolute value. Because if I'm going up, I need this number to be positive. I'm going to subtract this from my radius. So I'm going to say if radius minus row diff less than or equal to 0, return null. So it can't detect anything in that row. Otherwise, the leftmost is otherwise we return int new, all right, we'll store this. Int new radius equals radius minus row diff. New radius is less than or equal to 0. Return 0. Otherwise, we're gonna do new range. It's this dot column minus new radius, this dot column plus new radius. Yeah. And is it just less than 0? I think it's if it's less than 0. Because if it is 0, it will just say like, well, I can detect things in this space. I don't think that'll actually ever happen. But well, I guess it could. Yeah. I guess it could, because if the beacon was just like in the same spot. All right, cool. So I think that gives me the range at a specific row. So now I can say for every... So now I got to sort of parse my sensors in. So I need to sort of calculate. I need to be able to construct a sensor in the following way. So it'll be public, given a position that's the beacon, public static sensor, public static sensor, I guess I could write a parse method that just parses this in and calculates that. I think that's what I'll do. This is... not that hard to parse, but... parse string row looks like this. We are going to consume this much. Brain work, brain work. All right, we're gonna 0, 1, 2, 3, 4, 5. Oops. This is, I wish I knew a parser combinator library. All right, so I need to consume that many characters. So I'm gonna say row.index of, can I put a string here? Index of x equals, or I'm just gonna find, hang on, row.index of equals. Okay. And then, oh, why is this? I could use a regular expression, but I don't want to have to write that. I'm going to find the first equal. Row index of, I'm going to find the first comma. X start, int x end. Int dot parse yeah, it's a little bit more splitting than I kind of want to do. So what I want to do is I want to say, well, I want to just consume up to here, parse an int, and then consume this string, parse an int, then consume this string, parse an int. That's what I'm gonna do. I'm gonna do that. All I'm gonna write a dumb thing here. I want a parser combinator, but let's do this real quick. Public static void consume string to consume and a queue of care data. And then we'll just go through and we'll pull out that many things. I didn't mean to delete my comment there. Yeah, so that's... I could just do a regular expression to match on number, can't I? Is that what I should do? My brain's not awake yet, so thank you for the advice. My brain wants to do it this way for some reason. Here, let's put this back in here. Where'd we go? I want to... Well, what I want to do is have two things like this. I want a public static int parse int q care data. I'm gonna do something dumb because this is what my brain wants me to do right now. So feel free to laugh at me because I can't. My brain can't. This is what my brain wants to do, and sometimes when your brain wants to do something, it's hard to shift it, and that's how we end up in terrible places like last time when we were 2 days ago when I wanted to write, you know, create Haskell style lists in C#. Let's do it. So the idea would be we're gonna create a queue of care data equals new, and then we're gonna do row dot to array dot for to list dot for each data dot in queue. We're gonna load all our data in there, and then we're gonna call consume this. If I split on equals, comma, and colon, you can then try parse. Oh, that's fun. That's actually probably what I should do. We're gonna be crazy, Keith. Keith, let me be crazy. Let me just be insane here. So we're gonna do int x. This is gonna be sensor x. Oh, what's going on? There we go. Sensor x equals parse int data, and then we're gonna consume. So I have admitted that this is stupid, and just let me be stupid. Let me be stupid. Really, I just am like, oh, I wish there was a parser combinator library I could use to just do this for me. All right, we're gonna let ourselves be stupid. And sensor y, and of course this is probably not gonna work. And then we're gonna consume. I'm gonna have to rewrite this anyway for my students. Oh no, we can have negative numbers. No, I don't want negative numbers. Int beacon x equals parse int data consume. That negative number makes me sad. It's gonna be slightly more annoying. Look, see, this is doing the exact same thing as split, but look how much more efficient. Look how much programming practice I'm getting. See, if I was better at regular expressions, I could just write a regular expression that says, oh, this is the pattern here, where I have this thing. Look, Keith, it's not programming if you're not writing the most convoluted, hard to program thing ever. All right, we're gonna do it. We're gonna do your solution. Row dot split, and I didn't know this. You can pass in like an array. Let's see. What is it? You can give it like several separators. Yeah, new string array. Keith is saying if we do equals, comma, colon. All right, everyone's. Can I just do this? Do I need new? New string. Don't need string, new array. What's it complaining about? Can I convert from string array? Oh. Interesting. That's fine. Okay. We're gonna split it there. And then we're going to select, we're gonna where int dot try parse s. Can I just ignore out int ignored dot select int dot parse dot to array nums. Okay, fine. Don't let me write a parser. That's okay. This makes sense. This makes sense. And then we're gonna say that we have to calculate the Manhattan distance. So we're gonna have int beacon x equals nums of 0. Beacon y. This is just gonna help my brain. No, this is sensor. Sensor x. Thank you, Keith. That was... You saved me from myself. Once again, Keith saving me from myself. This is the ultimate pair programming exercise here. You program with anyone in the world. Okay, so the Manhattan distance, int radius. What is it? It's the math.absolute. I better look this up, but I'm pretty sure I can do sensor x minus beacon x plus math.absolute sensor y minus beacon y. Let's double check that. Manhattan distance. Manhattan distance. x1 minus x2 plus y1 minus y2. Okay. According to this quick Google, I was correct. So we'll just assume correctness. Return new sensor, row sensor y, sensor x, radius. Okay, we can parse in our sensors now. Let's do a quick test for sanity. String array rows equals file.read all lines example.txt. Example.txt. Sensors equals rows dot select sensor dot parse dot to array for each sensor s in sensors console dot write line s .NET run project solution. Oh, Cessnar. And I'm in the wrong project. Hang on. .NET run project solution. All right, it parses. It doesn't crash. Let's check out. See if this is right. The one sensor that they give us sort of this example on is the one that's at position 8,7. 8, 7 had a radius of 9. Okay, that's exactly how I liked it. Okay, so now let's get the ranges here. So s.range at row. We're specifically looking at row 10. Here, range at row 10. Console.writeLine range at row 10. Cool. And so then we just sort of find the lower and upper bounds. The lowest one is negative. Well, if there's gaps, there's a problem. So I can't quite do this. I need to sort of check if there's gaps, and if there's gaps I need to do something. So maybe I have like a set. I try and merge ranges together, and if I can't, I need to have like a list of ranges or a set of ranges or something. But the idea here is that the lower range would be -2, the upper range would be 24, so there's 26 positions. Okay. But my ranges, yeah, can have gaps. The lowers that are at 2? Well, I can sort of ignore, I understand that sometimes there's going to be gaps in them, right? Look at the lowers that are 2. Lower, upper. This one happens to sort of overlap with that same beacon. I don't quite understand your comment, Keith. But yeah, I need a way to sort of merge these together, and then I have, if they're overlapping, I can just merge them together. Oh, gotcha. And then if they're not overlapping, I sort of have a list there, and then I can sort of say, okay, well, where I can sort of identify the gaps there. But if they're not overlapping, I keep the list and I sum. Okay, cool. The delay got me, I think, on that one, as far as you saying look at those ones. So this was part like day 4 or 5 or something we did this. I should, if I was smart, I'd be building up utilities for this, but I haven't, so we're just gonna rewrite it. So we're gonna have public static public bool is overlapping range other public range merge range other. So we're gonna merge them together. The thing is, well, this could be, there's gonna be some inefficiency here because I kind of need to keep merging. So if I take two and I merge them together, they might now, let me think. I'm thinking of like this weird situation, not necessarily a weird situation, but a situation where I compare two. I need to sort of sort them. Yeah. So if I sort them from leftmost up, then we'll be able to merge them in order. So yeah, I got to sort them first. So I'll sort my ranges, then I merge sort of left to right. Yeah, I've noticed that when I've finished these and I've gone to look at some people, it's what are some of these functions doing, and some of them are just so obscurely difficult to read. It's gnarly. All right. So I have a question. This is a weird question. When I drink my coffee, can you guys hear me drinking my coffee? I'm a little self-conscious of it. Maybe I shouldn't ask, because now if I know that you can hear me drinking my coffee, it's gonna make me super self-conscious. Okay. Okay, cool. I have my new microphone, and so this is a like really not a high quality, but I was using like a $20 microphone. Now I have a better microphone, and the sensitivity, I wasn't sure if it was picking stuff up. I've recorded in my videos, I can like anyway, don't worry about it. Thank you for making me less self-conscious. So we're overlapping if God, why can't all right. So I've had it for several days. I just haven't spoken about it. Yeah. All right. So return if I'm gonna draw myself a little picture here just to make my brain okay. I need to do that here. Okay. So I've drawn a little picture that looks like this. I have there's essentially sort of two cases where you have overlapping. You have this, and then so this middle one is what I need to consider, right? So I'm overlapping if the upper of, so this would be other, and this would be other, and this would be this. So if the upper, and I kind of got like inverse it, I think, too, as well. So if the upper is, and technically they're overlapping here. So if I do that, it's a little bit better. If the upper okay, so we'll write it out as a series of ifs here. If other dot upper is greater than or equal to this dot lower, so then it would be true, or other dot lower is less than or equal to this dot upper. So that's going to tell me if the left one so now if we have this here, and this is other, and this is this. In this case, we have or this dot upper greater than or equal to other dot lower, or this dot lower less than or equal to this dot upper. I'm not sure if these are redundant. This dot upper, other dot lower. Yeah, these are redundant. I think this is all I need here. Someone in Keith or G, if you guys see a glaring error here, please let me know. Okay, so then merging them becomes relatively easy. If one of the points inside A is inside of the range of B, then it overlaps. Yeah, so I think this covers that situation. It's just translating it to that Boolean logic always hurts my brain a little bit. So merging is pretty easy here. We're gonna say if. Well, I was gonna add a little check here. In the morning, it really hurts, right? So I had to draw this little picture to like keep my brain thinking it's all right. I'm gonna return a new range. So we'll do a quick min equals this math dot min of this dot lower other dot lower dot max equals math dot max this dot upper other dot upper. And just for safety, we're gonna say if this dot other of this dot is overlapping other. If it's not, throw new exception, cannot merge disjoint ranges. And we'll return new range with min and max. So the idea would be now I can merge these together. And I was saying if I sort them, I should probably really write some tests. That's the correct thing to do, G. But none of my students are here, so so no one's here to say. But you make us write tests. And it's you know, it's fun to see how much. Sometimes it's fun to see how far your brain can take you before you have to just really start reasoning about something. It's a nice little muscle to flex. Sometimes the brain's not really a muscle, though, right? Sometimes it feels that way. Okay. So now I can merge them. If they're not overlapping, I sort of need to. So hopefully they're all overlapping at. Yeah. That would just be nice if they were all overlapping at that position. That would be the hacky thing to do. Otherwise, I sort of need to keep. But I imagine later on that's not going to be the case. So otherwise I need to keep like lists of, well, yeah. So let's sort it. So is there a sensors.sort? No. I can do an order by. Dot. Let's do this. Rows. So don't tell me part 2 just yet. I want to be horrified. Can I write? Then I have to write a comparator for that key. So it's going to be S goes to S dot S dot. Well, let's turn these all into ranges actually. Dot select. It's dot range. Eating some soup. What kind of soup you got there? This is like soup. It's winter here. I'm not sure where you are, but it's soup season, man. I love some good soups. Range at row 10. Let's make this a var for now. And then we're gonna order by S goes to S dot lower. Maybe null. Okay. Dot where S is not equal to null. So I know that S can't be null here. To array. So this should get me a sorted range array. Sorted. It's mostly water because it already has vegetables and pasta in it. What is this? Nullability of reference types in value of range. Okay, I need to write something here. Public bool has range at row. Row. And it's this. And then here we'll say if it greater than 0, so its new radius is greater than 0, greater than or equal to 0. All right, so if has range at row, grumpy noises because I don't like this. Hang on. We're gonna just do an assertion here. If it doesn't have a range at that row, new exception. Could not get range. This just shouldn't happen. And now I'm gonna make this get me just ranges. Dot where S dot has range at row 10. All right. Int y equals 10. Where, all right, so now we can order by lower. And we'll do our in ranges. Really, I could do an aggregate here. Not quite. Range start equals ranges of 0. We'll assume we have at least one. List of range ranges. So this is going to account for the case. This should be disjoint ranges. if we find a range, if we end up not being able to merge them, I need to sort of start a new, rather than start, call this current. All right, so then we go through and we say current if current dot is overlapping R. So if it's not overlapping R, we add it to disjoint ranges dot add current. And then current equals R. So we weren't able to merge these together. So we say, okay, here's a chunk. There's going to be a gap, and then start over here. Else current equals current dot merge with R. And then at the end of the day, we should have current and then console dot write line there were disjoint ranges dot count disjoint ranges. All right. Okay, so in this case, it works out. Which and we'll just do a little getter here. Public int elements is equal to, nope, wrong spot in our range. Elements is equal to upper minus lower. There we go. So we get 26. All right. Cross our fingers. Woo, those are some big numbers. Not that. Let's make a new input, new file. Input that takes here. Are you sure about these the array of ranges? I don't understand the question. We're gonna try this. Oh. Well, so each individual range has a, these are inclusive ranges, right? Elements should be a bit more there. No, elements is 26 here. So it goes from 24 to -2. It is inclusive. That should be 26. We're not going to 10. We want 2 million. Let's try it. I think this is correct. Hey, we got a beautiful gold star. Let's be sad that our solution is not going to be efficient enough for the next part. Oh, your handheld device indicates that the distress signal is coming from a beacon nearby. The distress beacon is not detected by any sensor. But the distress beacon must have an XY coordinate each no lower than 0 and no larger than 4 million. Oh. To isolate the distress beacon signal, you need to determine its tuning frequency, which can be found by multiplying its X coordinate. And all right, so once we have it, then we can calculate its tuning frequency. So we need to all right. There are 27 spaces between -2 and 24. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Oh, so if a beacon happens, that makes sense. You're right. Okay. Oh. That could have caused me some pain. If you're right, because 0 counts. I was missing the 0 here. So we also need to have a set of all of our beacons and just make sure if there happens to be a beacon inside, we have to remove that beacon. So it's the number of, you're right, it's the number of spaces that the sensors can detect, but if there's a beacon in there, I need to subtract it out of that range. So I kind of need to keep track of my beacon positions. Public record beacon. Doesn't matter in part 2. I should still have it in here because I'm going to make a guide video. And in the guide video, I need to make sure I do this. So thank you for pointing that out. Column like this. And I'm going to make this. So I need to also have a beacon in here. So if I have this taking a beacon, be the radius can be calculated as this. Column B dot column row B dot row. Thank you, G. That's, I would have made a terrible video, so this is super helpful. I appreciate that so much. And then we pass in a beacon here. Okay. All right, so then we need to have all of our beacons. So in our program, all right, so I do need to keep my sensors. Sensors equals, I don't have to, but and then this becomes sensors dot, and then this becomes beacons. Janeth over on YouTube says, I am from Sri Lanka. Well, welcome. I am in Arizona, United States. But Janeth, thank you so much for popping in. We finished part 1. There's a bug in it. G here on Twitch pointed out that we have a bug that happened to slip by. If I'd written a unit test, I would have found this. Because I would have thought about it, I would have counted up, said, okay, I have 27 here. Yeah. Beacons, sensors dot select, S goes to S dot beacon. to array, and then I want to, in my range, I'm gonna be able to say if it contains a beacon. Public int beacon count. Beacons for each beacon be in beacons if int sum equals 0, return sum if b dot column greater than or equal to this dot lower, and b dot column less than or equal to this dot upper, sum plus plus. So we're gonna count all the beacons in there. We'll have console dot write line current dot count beacon count beacons. What do we say here? Specifically, they were saying these are not. None of the tech beacons are in this one where it isn't. All right. Distress signal is not in. Well, not sure what I'm doing. Channel is not in current dot elements minus positions. I've done something. Hang on, this is interesting. Oh, it also has to be in that row. Yeah. Not row equals row, and there we go. Yeah, I got lucky that there weren't anything there. Let's try example and int y equals 10. I've done something terrible. Hang on here. I gotta step away just for a moment. I'll be right back. And I'm back. Thank you for your patience. I apologize for that. I think my parse, I've done something wrong. Yeah, these are backwards. This is why row and column, X and Y gets me confused. Yeah, there we go. 27 elements. Well, now this isn't wrong. This is still wrong. It should be 26. My program. Let's only keep where beacon dot row is equal to Y. Let's get rid of this Y here. If let me just sort it out here. Get rid of this stupid thing. So now I only have beacons. Console.writeLine. Beacons string.join comma. I want to just see what beacons I have there. Should just write a unit test, man. String.join. Two-string? Two-string. This should be array of objects, beacons. Calls ambiguous between the following properties. Dot select B goes to B dot toString. That felt weird. So beacons in row 10. Oh, this needs to be a hash set. So we're getting cut. That makes sense. There we go. Okay. And then we can just remove it if it happens to be in that range. So beacons dot where beacon dot column beacon dot column is greater than or equal to current dot here. We'll add a contains. Public bool contains int x. And this is just it's greater than or equal to this dot lower. And x less than or equal to this dot upper. Beacons dot select B goes to current dot contains B dot column dot count beacon count. Okay. All right, there we go. Yikes. Again, thank you so much, Chief. Horrible later on. for when I was trying to explain this to students. Okay, here we are, part 2. We need to actually identify some. So this is interesting. We have, yeah. So my question, so my initial thought is a quad tree, but our our so we have like these diamonds. So a quad tree, if this thing were not diamonds, I could just do a quad tree and find the space. Start with my range 0 to 4 million and be like, all right, just keep chopping in, recursively searching for a position that none of the sensors are overlapping. So essentially that's what we're looking for, is there's going to be a position somewhere that no things overlap. So in this case, I think in the example, it's row 11 right here. There's nothing overlapping. So we need to find a position. So what we could do, and I'm not sure this is, the brute force way would be to loop through all rows, 0 to 4 million, right? And if we find a disjoint range, I know. If we find a disjoint range, then we found it, right? So we don't actually have to go through every position. We need to, we only actually, we're not going to do 4 million every position in that grid. Instead, we're going to say, what is our range of coverage for row 0? What is our range of coverage for row 1? Right, and then you look for the disjoint set where there's a gap between it. I think that's the solution. Let me wrap this in part 1 here. Void part 1. So you don't actually have to iterate over every position. Instead, you just look at ranges, sensors that matter for each row, and then find a disjoint set, because it sort of implies so if I look at my input here, yeah, that's interesting. Yeah, so I have like these giant radiuses. I don't know. So here's my thought. I want to be able to tell my students an approach for part 2 that uses that isn't so crazy different from part 1 that they can't solve it. So I could do, so essentially, what I could do is, I'm pretty sure because of our the way this is set up, I could build a structure that does quad trees on rectangles that are on diamonds, essentially. So I can break down my search space for sort of the quadrant to the left, the quadrant to the above. So I shift this halfway between, and now I have a sensor that has half the radius and over. But I don't want to have to, like, quad trees are hard enough. Not hard enough, but quad trees are challenging enough to explain in not diamond land, that now if we translate it to a problem where we are in diamond land, it's a little bit harder. But yeah, we take our what you could do is you say, okay, well I take my radius of this S and I break it into 4 smaller radiuses, and that becomes my search space, and I just keep recursively zooming into that space until I find where there's a hole. Right. So that would be like a more efficient method. I don't know if it's the most efficient method. Another thing to consider, something else you might consider, something that just popped into my mind here is, we know if we increase our radius by 1, we can sort of walk the outside of our radius. So what we could do is we could walk the outside of our radius and build ranges that are sort of from here to here, here to here. And so you should end up sort of with like an intersection, and you between your other sensors, right? So you end up with like this matrix of lines all intersecting with each other, and then you can use that to find a spot. Yeah, so I'm pretty sure I could actually, the spaces that are important to search. So here's a brute force search. The spaces that are important to search happen to be the ones along just outside the sensor's range. So I could do a walk where I say, okay, well, what are the positions that I need to check? So, and I could build up a smaller search space and then iterate over those. I think that solution would also work, but it doesn't really use our solution from anything from part 1. So I'm going to see if I can do part 1 first, where I say, okay, what are my range for row 0? What is my range for row 1? So I'm going to iterate over 4 million rows. It's going to be slow. It's going to be slow. Void part 2. So we're going to do 4 int y equals 0. Y is less than 4. Well, let's not do that just yet. Let's, in this example, well, and you can sort of stop early. As soon as you find a disjoint, you should be good. Let's look at our example input. We need to find the biggest y. Yeah. Well, I can even reduce my search space a little bit more. So if I have all of my sensors, all right. So I know my min y is going to be 0, and my min x is going to be 0. And then if I iterate over this, so for each sensor as in sensors, I'm trying to come up with a naive solution to this that will work. Min y equals math.max. All right, so I know this is actually our max y. Math.max s. I'm gonna call this row. S dot row all row. And max row and max column. So now we sort of know. Oh, not quite, because we want to plus s dot radius. Plus s dot radius. There we go. So this is going to give us console.writeLine max row max call. Let's see what this tells us. Project solution. And I gotta go in 30 minutes, so I'm probably not gonna finish this. So this shows me sort of like the range. All right, what is it for my input? That's my max anyway. So the max are gonna be 4 million. Anyway. Math.min. But it, the min of these two, but also at least 4 million. Oh, I can do lamp. I don't know. My brain can't handle it right now. This should just get me back 4 million on each of those. All right, so that is my search space. That's fine. I do it on my example. Let's go back in time. All right, so we need to let's get our ranges as well. Oh, this is gonna be horrible. 4 int y equals 0, y less than 4 million. I don't think this is gonna work. Because then we have to do this essentially again. All right, so void find ranges. Sensor array. Should be this. Okay, so this would be ranges, sensors, y. 4 million iterations is stupid. Oh god. Will this even, all right. Console.writeLine. I finished. I just want to, like, how long is it going to take to do just this? Oh no. Okay. Not too long. All right, and then I need to build up. Not crazy long. For a second I was scared, and then I want to do this chunk, which is going to be list range disjoint sets, disjoint ranges, and I have to take in a range array ranges. And then we loop through, and we're going to return disjoint ranges. And at the very end, we go ahead and add it in. Whichever one was left at the end gets added in. So we need to be able to calculate our disjoint ranges here. List ranges. Disjoint. And we're going to say if disjoint.count is greater than 1, break console.writeLine and we could almost finish well, this isn't quite right either because, well, we'll see. Actually, I think this might work. This might work. Disjoint dot string dot join I should add a little thing in here telling me, oh no, there were no disjoint ranges. That can't be right. What? Hang on. Index was outside the bounds of the array. Let's pull this up here. It was able to run disjoint sets over everything, but without in under a minute. This might work if I can. What is this failing on? Oh, if I have, if ranges.length equals 0, continue. Finished. This is interesting. This is interesting. So I know that this one, hang on, we're gonna put we're gonna do a little bit of print line debugging. Console.readLine. We're gonna pause each row. Print out every row we do. We're gonna print out some information. Console.writeLine. String.join. Ranges. Dot to list. Why? This is so weird. Dot select. Dot to string. Oh, it's because I just don't have a comma. I need this. I do. To list. That's so weird to me. I don't like that. Console.writeLine y equals and then console.writeLine string.join console.writeLine ranges console.writeLine disjoint that. Okay. So hopefully this will give me a little bit more, looking at my example of what I'm doing wrong. So this is y1. So I'm at 11. At 11, I should have a disjoint set. Or so I thought. Example, row 10. In the row where y equals 10, there are 26% where beacon can't be present. Yeah. In the example of the search space spelling, instead x and y coordinate can each be at most 20. With this reduced search area, there is only a single position that could have a beacon. Yeah. So like I'm a little bit. My logic didn't work out. Int range equals 20. Max range. Don't quite understand why I don't have a disjoint set there. The way I calculate my disjoint set must be incorrect. Yeah, so let's look at my ranges for row 11, because they must be incorrect. The way I'm merging them must be incorrect. Is that a break between them? Oh, I added that in the wrong spot. Okay, so at y equals 11, -3 to 3. I need to, okay, so one thing I need to do is these ranges, I need to sort of stop at 0 and stop at the max range. So that's one thing I'm missing here. I don't know if that would actually affect this. But I'm gonna draw. All right, so let me do that real quick. My ranges, I need to select R is going to be a R with row equal to math dot max. I need a clamp, math dot clamp. The value I'm clamping is R dot row. Hang on, let me make sure I have this syntax right. Row equals 0. Ranges. Oh, lower. With lower equal to 0. Dot to array. Okay. So, and apparently using arrays is not, I have to convert it back to a list anyway, which is annoying. All right, so lower is equal to math.clamp lower, r.lower. And then it's going to be between 0 and max range. And then our upper is going to be math.clamp our dot upper between 0 and match range. Okay, so that now our ranges should be clamped in there. Okay, so let's draw this out. They're sorted by our lowers as well. So let's see if my brain can handle this. All right, so we have 0, 1, 2, 3. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 0. And then what is the next one here? 3 to 13. And then 11 to 13. And then 15 to 20. And then 15 to 17. Okay. So my is overlapping or my merge is wrong. Because there is a gap here. Oh, thanks. I appreciate that as well. All right, so I have a hole here. Something's wrong with my merge. Or with my is overlapping. So I'm going to write a little unit test here to figure it out. So my is overlapping. Remember when we were talking about is overlapping? I'm assuming there's a bug in my is overlapping. All right, let's call this range test. Range test. 15 minutes. 15 minutes. Test. Range is overlapping. All right, so where I'm failing is sort of this example. So I'm going to build a unit test for, come on, this example. Range r equals new range 0 to 3. Ranges, and we'll label these. No. R0 range R1 equals new range 2. Let's call this range. Make it an array. So that new range 2, 2, new range 3 to 13, new range 10 to 13, new range 15 to 20, new range 15 to 17. Okay. And so we should sort of just merge down, right? So as we're merging down, I should be able to do assert true ranges 0 dot is overlapping with ranges 1. And then range expected is going to be range 0, 3. And so when I merge these together, assert equal expected ranges 0 dot merge ranges 1. So I'll do range result equals this because I'm going to be accumulating this thing. Results. Then assert true ranges, not ranges, assert true results dot is overlapping ranges of 2. Expected is going to be a new range of 0 to 13. Assert, and then the result is going to be result.merge with ranges at 2. Assert equal expected and result. This here, assert true result.is overlapping ranges 3. Sorry, set labels here 0, 1, 2, 3, 4, 5. Just for my brain. Assert, and then expected is the same range, 0 to 13. Result equals result.merge ranges of 3. Assert dot equal expected result. Now that shouldn't be overlapping, assert false. That's where I'm going to fail. Result.is overlapping ranges 4. Or hope it should be false here. And if it's not, then I'm happy and then the bug's somewhere else. Is essentially what it is. Expected. Oh, we can't merge them. So we shouldn't be able to merge them. So maybe I am accidentally merging them here. And so now our new result should be this one. And then we should be able to assert true result dot is overlapping ranges 5. And then the expected is the same thing here, 15, 20. Third dot equal expected results. And I gotta actually run merge results equals result dot merge ranges 5. Okay, so we have a little unit test here. Okay, and I fail on this is overlapping. Let's check it out. Let's check out why my logic is failing. Let's step into this. So this has a lower of 0 and an upper of 13. And this has a lower of 15 and an upper of 20. So other dot upper is 20, which is greater than or equal to the lower. So it's returning true. Does this need to be an and? Okay, so something's... So I am missing something here. This is exactly what we remember. G, this is what you told me. You said overlapping is hard. I felt like there should be 4 conditions here. So this one's not overlapping. All right. Okay, so come on, brain. Come on, brain. You can do this. If any of the positions in one is overlapping. So I have 0 to 13. All right, so I'm not overlapping. All right, so I have this case 0. I have a case now here like this. This should not be overlapping. So although my upper is to be oh, my other's on the other side of this. So I need to consider these cases. Yeah. So this is just considering the case where I'm to the left or to the right. Oh man. Why is this so hard? Other this. So I'm not overlapping. The inverse needs to be true, right? All right, so it's this. If Smab, welcome aboard. I hope you're doing well. I'm trying to come up with a naive solution for part 2. I have a bug in my is overlapping. I managed to get part 1 working, but my overlapping here is broken, which is causing me a little bit of pain because for some reason my brain cannot figure it out easily. For some reason this is hard for my brain to do, and but I think I have a solution that's relatively naive. I have a relatively naive. So my initial thought was, oh well, I could do quad trees, build some quad tree to do it on diamonds. Oh, you don't. All right, so I have a solution for part 1. I'm almost done with my naive solution for part 2. It's gonna work. It's gonna be slow though, so it's gonna take like a minute to run. So if you don't want spoilers for part 2, maybe not a good time. Not that I don't want you here, but if you don't want spoilers, would you like to hear my naive approach? So my brute force is gonna be good. Okay, so I'm gonna come back to this. Let me stop what I'm doing here. I need to fix this. All right, so here is my naive version. The fast approach would be to do quad trees, and So I'm going to tell you like the efficient version that I'm not doing. So every sensor has a radius, and then you could quad tree it. Say, okay, well, take that sensor, divide its radius in half, and then create a new sensor at each of the positions north, east, south, and west. And then you recursively search for the spot that you're missing. All right, so you could do a quad tree like that and find overlapping. All right, so don't worry about quad trees. The reason I didn't want to do quad trees is because they're hard enough to do in a non-diamond pattern. So we're not going to do quad trees. My naive approach is the following. I have written this function disjoint ranges. All right, so let me first talk about my part one. The way I do part one is I have determined that given a sensor S that is at a position, can I determine the range of values given another row that it has? So for example, a sensor S in row 12 can see these ranges. You can do this by subtracting the distance from this sensor to that position and constructing a range based on the radius minus that sensor. So you can get a range from left to right. So we have a lower and an upper range for every sensor for every row. Then with that, I can iterate over that row and determine whether or not there's a disjoint set. So if I have disjoint ranges, then I know that there's a space in the middle. So I sort of merge my ranges together for all of my sensors. I merge the ranges together for that row, which tells me the spanning range. But I don't merge if there's a gap in the middle. So I have this function is overlapping. And if it's not overlapping, they're disjoints. The ranges, there's a hole in it. So then I loop through all of my Y positions. It's pretty inefficient because I have to loop through all of my Y positions. And for each Y position, I say, okay, what are the sensors ranges for this Y position? Then I say, are those ranges disjoint? If they are, there's a gap. And then you just find out what that gap is. I know. I'm trying not to look back at it because it's good to flex my brain. That's exactly what I said at the beginning of the stream. I was like, oh, we did this in day 4. I probably should have a util library to redo this. I'm running out of time here, so I might just go look at day 4. I have so many things. Day 4. Yeah, I'm gonna do it. Let's go. Still, my is overlapping here because I wrote a range on this one as well. Oh no. Did not get committed. How many day 4s do I have though? Oh, that's day 4. CD day 4 C#. Yeah, so I did something really weird here. I didn't write this in a really obvious way at all. Range extension. Okay, let's steal this range thing. Range extensions. So this is now lower. 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 Upper. Upper. That was upper, right? Yeah. Upper. Hang on, let me just... Yeah. I wrote a weird solution for this one too. Start replace with upper start dot value. And end dot value. Jeez. Should become. Hang on, I did the wrong thing. Undo. This needs to come lower. And N upper. Tried getting my head around what might be needed for intersecting ranges, but couldn't come up with the right process. Yeah, so if you sort, if you sort the ranges such that the lower part's on the left, you can merge them down just in order. Say, so you keep merging until you find a gap, and you say, okay, well this thing goes on the left, and then you merge everything on the right. You keep, so anyway, you'll find a gap there. And then I should have this is overlapping. Public static. This. Oh, I don't know. Look at me being smart here. Is overlapping and intersects are the same. So now I can just get rid of this. Oh. And do intersects. Okay. Let's test my intersects here. Intersects. Oh, it's not a compiler error. I do have a compiler error though, probably on my program. This should be now intersects. Yeah, gee, I should have streamed. There was a bug in that one. And it's probably the exact same bug I have here where I'm not considering all the cases. There we go. I'm gonna rename this test range intersects. Okay, so now my hope is with this working intersects .NET run project solution. All right, so here we are. It should detect on y equals 11. We should end up with a disjoint set. Yes. So on y equals 11, we found a disjoint set from this range to this range. So there's a gap between them. So it exits out, and now I can find, I just look at the element to the right of the upper of this range. Congrats on getting sets right. Yeah, congrats to previous me for finding it. All right, so now my max range is gonna be 4 million. I'm not gonna print out any diagnostics. I do need, my solution is gonna be here. Found a disjoint set, console.writeLine. What is this? The distress signal is at disjoint 0 dot upper +1 comma y. All right, so this is the short version here, or the short version. This is my naive version. Gee, thank you so much for hanging out. I think I'm gonna get it here. .NET run project solution. Let's change this to 220 and example, just to make sure that it's actually producing the correct number. Oh. Oh, it's waiting for me to press enter. Whew. I am glad I decided to test that first, because that would have been horrible. All right, so x14, y11, and then I have to calculate the value here. So the value, so I'll do int x equals this, and the frequency for million, x times 4 million plus y, and freq equals x times this. I'm not sure this is 4 million plus y. Console.writeLine frequency is freq. Sweet. Okay, so I really, which is okay. All right, so it's gonna be slow here. 4 million. Oh, so I need to do a long. Thank you. I would have been sad. Do a long here. And let's do overkill because I'm bad. Just make sure I don't have any errors here. Put an L. All right, so now it's telling me I don't have to do that. Okay. All right, it's gonna be slow, but fast enough. I've reduced my search space enough. Okay. Let's try it. All right. Just a little over time, 12 minutes longer than I wanted to be, or 10 minutes past the hour. So it took me a little bit longer. Thank you. Ooh, look at that reveal. Yeah, so the way so here is my part 1. Just so you can see what I'm doing. Real quick, I'm teaching a class in about 50 minutes, so I got a little bit of time. It's the last class of the semester for them, so we're not doing anything. I don't have to prep too much. So my sensor is defined in the following way. It has a row, a column, and a beacon. And the radius is determined by the Manhattan distance to that beacon. And then I'm able to get a range at that row. So I can give it a row and it's gonna either tell me, hey, I can't do that, or give me a range showing the leftmost position, the rightmost position for that row that this sensor can detect. So that is how I get my ranges. The important thing here is that the reason my search works is because I sort my ranges such that they're in order where the lowest one is on the left. So as I'm going left to right, the merges will work. The merges will work as I go left to right to put them together. If I didn't do this, I'd have to do it pairwise. I'd say, okay, I have to keep merging until I can't merge. And so I could do, it would be okay to do that, but worst case, you have n squared for your sensor, for your ranges. Although you don't have that many sensors, right? How many sensors do I have? You don't have that many sensors, so your search space shouldn't be too bad if you want to merge them all together that way. Then I find whether or not they're... In the first one, there were no disjoint ranges. Or I actually had a bug. I actually had a bug in my solution. But for that row, there isn't a disjoint range. So you just sort of merge them together. So you look through all the ranges in that row and you just say, okay, keep combining these. And then you find it. What a shorter version would be to just say, okay, find the minimum and the maximum. So I could loop through all my ranges, find the minimum, maximum, and return that. But I merge them together and detect if I'm disjoint. I did this because I wasn't sure if I'd end up being disjoint. It would be interesting if I was. And then I can use this. So I ended up writing disjoint ranges to give me back a list of my ranges. If there's one thing in it, it's not disjoint, it all has one. But yeah, so this really reduced my search space quite a bit. An alternate approach would be to check each position. So you go to the edge of your you could build up a search space in the following way too. So this puzzle's cool because there's lots of different algorithms for it. So we have S. You go to your radius +1. So you know that the distress signal is going to be in a position that's borders one of your sensors. So you could calculate the positions of everything on the border of your sensors. And then you say, okay, well, I'm going to search. This is just the search space I'm going to have. I'm going to search all of these. It's going to be one of these. And you just basically check to say whether or not... well, then you still have to build up your... Yeah, so those become your spaces that you're going to search. All of your XY positions. I still think that's... could be pretty slow because you have to check it against every other sensor. Oh, no, that's fast because you don't have that many sensors. You just say, okay, all these spaces, check every sensor. If it's in there, I'm not there. Otherwise, I pull it out. Okay, that solution I think is pretty good. Doesn't use part 1. In fact, my disjoint ranges thing here isn't even necessary for part 1. 7 million points. Interesting. I wonder what the actual running time for me is. A quad tree is the way to go, I think. I might take a crack at writing myself an efficient quad tree, though this speed is not too bad. Project solution. I know I have my constant here happens to be 4 million, so it's like O of 1 times n. So my n, I'm searching 4 million, so it's 4 million, and then each row takes calculating the ranges and sorting them. So every sensor, so I have n is my sensor. All right, so n is number of sensors. Yeah. Well, but I end up sorting my ranges, so it ends up being not quite that. So my ability to detect my range is constant. 7 million times the number of beacons. Gotcha. N is the number of sensors. So then I end up with n ranges. All right. And then I have to do O of n log n because I have to sort them. So n log n to sort ranges. And so it's 4 million times n times log n. Interesting. Because I have to sort, every time I have to sort my ranges. Yours, I actually think your solution is faster, but the number of points you have to search grows depending on the distances, right? Anyway, I'm happy with this. This disjoint ranges thing is a little tricky. All right. Well, thank you for hanging out, G. I know you gotta go. You're in overtime at this point. Thanks for hanging out and chatting with me, helping me through the pain. Let me commit this. Take it easy, my friend. Sure. Solution for day 15, part 1 and 2. 2 is quite naive. But yeah, I think the I think a very efficient solution would be to do a quad tree. All right, I'm heading out. Have a beautiful day. Thanks for hanging out, and come on back anytime.